Hudson, Senior Director of Product Marketing at Infoblox. I have with me Aditi from Microsoft, who will also talk a little bit later in the presentation. So the topic for today is enabling modern zero trust. I'm sure all of you have heard of zero trust and what it is. It's no surprise to anybody. And today we're going to talk about a slightly different angle on zero trust, one that's often overlooked, and we'll talk about what that is. But from a setting the stage perspective, we all know that many organizations, many companies are embarking on zero trust. Some of them have kind of partially started their journey. Some of them have, almost done more towards a fully zero trust kind of implementation and approach. But it's a journey. It's not one and done. And as you can see here, about more than 60% are doing some sort of zero trust in their organization, and many of them are doing it because it is a best practice, right? When you think about how you want to protect your networks against cyber attacks, zero trust is a very good, robust approach to do that. So why zero trust? We all know that companies' networks are getting complex, right? Nobody's doing just on-prem networks anymore. Your workloads are moving to the cloud. More than I would say 80% of organizations are using a multi-cloud approach. So they're going for more than at least two or more public cloud providers. Most of it is hybrid. So networks are getting more complex, which means that you're securing those networks is getting more difficult, right? So that's one aspect. The second aspect is threat actors are getting more sophisticated. They're using AI to automate attacks. They're using AI to develop more targeted phishing attacks. And they're using things like traffic distribution systems and cloaking methods to avoid detection. So when they're getting more sophisticated, breaches are likely to happen, right? Zero trust will help you in the sense that if there is a breach, a zero trust approach will help you contain that breach, limit the scope of that breach before it spreads laterally within your networks, right? That's the number one kind of benefit of a zero trust approach. And we all know the standard tenets of zero trust, right? You always assume a breach is going to happen. You're always, you're not trusting. You always verify before you trust a device or a user from accessing any sort of application or resource. Always use a least privilege approach and constantly monitor. You have to constantly monitor your network traffic for anomalies, suspicious patterns, and all connections, all traffic from your devices, users, applications, and workloads, right? And of course, segmentation. The more you kind of do strategic segmentation of your networks, the better you're able to contain a breach so that even if one segment is compromised, it doesn't spread to the rest of your network. So standard tenets for zero trust, everybody's aware of that. But one thing not everybody's aware of is you're not really doing zero trust if you're implicitly trusting DNS. So your DNS is the one infrastructure element that is connecting all users, workloads, devices to any destination on the internet, right? And if you're allowing your DNS servers to connect wherever the user or device is requesting access to, you're implicitly trusting DNS, which means you're not really doing a zero trust approach, right? So the rest of this talk is about what zero trust DNS actually means, right? So if you remember those tenets we talked about, DNS has a role to play in many of those tenets. Number one is always never trust, always verify. If you should always use a protective DNS-based solution to check if your users or devices are going to high-risk domains or malicious domains. Don't assume that all DNS traffic is legit, right? So you've got to use what's called DNS-based threat intel to either allow a user or device to go to a destination, to allow that resolution or not, based on threat intelligence. The second thing is you have to always continuously monitor DNS traffic that's going out to external destinations on the internet and check if it's doing things like data exfiltration. Is data getting exfiltrated via DNS? Do you see DGA traffic, domain generation algorithm traffic, things like that? You can only identify these type of threats if you're constantly monitoring your DNS traffic that's going out from your networks to the internet. So this kind of fills that gap that we talked about for zero trust as it relates to DNS. The other part is also encryption. So you want to make sure your DNS traffic is not plain text, but it should be encrypted either using DNS over TLS or DOT or DNS over HTTPS, which is called DOE. That encryption will prevent bad actors from snooping into your DNS traffic and kind of hijacking that DNS traffic, right? Because it'll tell those bad actors where the users are going, where what the destinations are being accessed. So if you use encrypted DNS, you're protecting the privacy of your DNS traffic. And then if you use protective DNS, you are able to identify traffic going to malicious destinations and block initial infection of users and devices. They're also able to detect command and control communications that happen over DNS, and you're able to block data exfiltration over DNS as well. Right? Now, Microsoft has taken this one step further, and I'm going to have Aditi come and talk about what Microsoft is doing to lock down devices to ensure that any DNS queries that are going out from Windows laptops goes to only trusted destinations.
To talk a bit about what Microsoft has started doing in this field, first of all, let's give a huge shout out to Kupa, who's done an amazing job at explaining us and getting us set up for this. So, to talk about specifically what Microsoft has done, most recently we announced the new product that we are calling Zero Trust DNS that ships in box in Windows. So, if you have a Windows 11 device today, it is available for you to test it out. What it does is it's an enterprise security feature through which, if you have a Windows 11 device with CTDNS enabled on it, we also call it CTDNS or Zero Trust DNS. It will make sure that all of your DNS traffic leaving that device is encrypted. So it uses DNS or HTTPS or DNS or TLS. And we make sure all of that traffic is only sent to your trusted DNS server that you set as a trusted server. So in this case, we did test with Infoblox. So that is one partner that we can test with. But if you have any other DNS server provider that supports encrypted DNS today, so DNS over HTTPS or DNS over TLS, you can completely use CTDNS for that solution as well. We're completely vendor agnostic. And what it would do is all of your DNS traffic is sent via encrypted DNS, and it also makes sure that all outbound traffic from your device is blocked by default, and we only allow traffic to endpoints that are resolved by your trusted DNS servers. So if your trusted DNS server sees that you're not supposed to go to some social networking website, then you can still hear me, right? Hopefully. Okay, cool. So if your trusted DNS server tells you that you're not supposed to go to some social networking website, then it will not let you go there. But if your enterprise IT admin sees that you can go to some internal websites, you can go to Workday or any other thing that you need for employee productivity reasons, those domain names and those policies will sit in your protective DNS server. Those will be resolved, and then CTDS will, in time, set the allow exception for those. So that's how we adhere to the zero trust principles of block by default and then we allow based on exceptions. The way it has been set up, it works through the Windows Filtering platform. So we have full visibility being the system of every traffic and every packet that leaves the device. So we can ensure that even if a user within your enterprise knows the IP address of a website that they're not supposed to go to, they won't be able to go to because the system never saw that as a resolution to be trusted from the trusted DNS server. And we don't have an allow exception for that. So it gets blocked by default. Like the slide mentions, we are in a public preview today. So if you want to test out CTDNS today, you can go to aka.ms/CTDNS preview. That has all the instructions that you need to set up CTDNS on your Windows 11 device today and test it out.
What?
And lastly, the Infoblox team put together a demo on how they made CTDNS work with their PDNS server provider. So stitching it all together, CTDNS provides protection on the client, making sure that any user within your enterprise is not able to bypass the policies that have been set in your Protective DNS server. And Infoblox, being the Protective DNS server provider in this case, they make sure that all of the policies exist on their server. And these are a bunch of protections that Kuba has greatly put forward in the slide that you can read through. And anything else that you want to add?
So as you saw here, we have a working demo. So if you guys are interested in seeing the demo at the booth, we can show you kind of what a before and after looks like. We can show you kind of how, if Infoblox is a PDNS server and you've got a Windows machine that is doing zero trust DNS, how that will block any communications to malicious domains, and it uses encryption. And if there is any direct connection that's being attempted using an IP address, the zero trust DNS on the Windows laptop will block that connection, right? So that's it. It's very simple, very straightforward. So you can take a look at the demos that we have on the demo station, and we have a bunch of experts here who can also answer any questions that you may. Thank you.
Please give it up for